Hello world, here's Jorge, and let's continue learning about object detection in PyTorch. So in the last video, we defined a function called IMSC, image scaling, which essentially what it did was to take a tensor and rescale it, okay? So in this video, we are going to define a function that is going to take a 4D vector, as we indicated in the last video too. Here, we're going to take as an input tensor that has the number of cropped images n, color channel C, height, and width. And it's going to output arrangement of images. So we're going to have a mosaic where we're going to have all our cropped images displayed. All right. Okay, so let's do that. And to go through the process, what we're going to do is to just take as an example a random dummy tensor and say make operations on it to end up with this mosaic. Yeah. So let's do it. Random tensor. And we are going to leverage the say power of randomness and use a random tensor. And as an example, let's just take 6 images in the red, green, and blue color channels, and we're gonna have 2 as a height and 3 as a width. Okay, very simple tensor here. And what we're gonna do now is to just get a feeling of the different, so the shape of this tensor, because of course the shape is indicated by the actual input of torch random. But what, for convenience for later, we are gonna store the number. So the number of cropped images, okay, so which is 6. So in this case, we're gonna say just like number, and we're gonna store in the following way. We're gonna say random tensor, and we're gonna say okay, this is going to be the shape, and we want to store the first number, okay, which is going to be 6. Yeah. So all right, in that sense, well, also for clarity, it's not needed because I already did it above, but let's import torch. Yeah. Okay, so we have stored the number of cropped images, and we are now going to actually calculate the number of columns, okay, the number of columns that are going to conform our mosaic. Yeah, or basically better say the base number of columns, and you'll see why I say that later. So we're going to calculate this number of columns in the following way. So number of columns, so the number of columns are going to be equal to the square root of the number of cropped images, okay? And these, why are we doing this? Because our goal is to end up with a square-like mosaic, yeah? And using this criteria of setting the number of columns as actually round up of the square root of the number of cropped images is going to help to achieve that. Okay, so let's do that. Let's do the square root. We're gonna take we're gonna use actually NumPy. So let's import NumPy as NP, and we're gonna say okay, NP square root, and we are gonna have the square root of the number of cropped images. And what we want to do with this is to round it up. Okay, we want to get so the number that corresponds to, so the maximal, say for instance in this case we have 6. Yeah, so we're gonna get 3. Okay, we're gonna get a 3. So well, let's actually showcase that. So np dot, how do we do it? What is the say method? We use sail. Okay, sail is going to run it up. Yeah, and just to show that is actually going to be the number that we expect, let's print it out. Let's print it out. Exactly, you see, we get a 3 as output here. Fantastic. So now what we want to do is to set the number of rows of our mosaic. Okay, so number of rows, and to do this we are going to apply the following. We are going to say, okay, so we're going to have the number, so the number of cropped images plus the number of columns that we're going to have, number of columns, and to this we are going to subtract the -1, and we are going to use the Python division operator of /, which is going to round down, okay, round down our result, and we're going to divide it by the number of columns. Great. So let me show you, okay, number of columns, so number of rows in this case. Let me show you why it's useful to say operate with these say equations for number of columns and number of rows. So let's print out as well the number of columns. Okay, so you see we have number of columns equal to 3 and number of rows equal to 2. So let's play a bit around the number of cropped images to see what is going to be the configuration for our cropped image. Okay, so essentially we're gonna have so let's just change it for a bit. So if we have say 9 cropped images, these equations are going to distribute our images in a square of 3 by 3. Okay, as you can see, we will have 3 columns and 3 rows. Again, this is why it's convenient to use these equations, because they yield square-like configuration. So what is going to do in the case that it's not possible to fit our images within a perfect square? Well, in that case, it's going to actually add a column. Okay, so what do I mean by that? So instead of 9, now we're going to have 10. So that it's not going to fit in a perfect square. Rather, then we need to then extend the number of columns. So like this, we're going to get a rectangle. Okay, it's going to get a rectangle because we're going to have 4 columns and we're going to have 3 rows. Okay, so this is the type of configuration that we're going to say choose for our images to be displayed in. Okay, great. Now let's continue. Let's continue with our work and goal of having this function that is able to output the mosaic. And for that, we are going to need to store as independent variables the number of color channels, the height number, and the width number. So let's do that. So let's store color channels. Height and width. Okay, so we're gonna have color channel is gonna be a random tensor, and is going to be actually the first. Yeah, actually the second element, in this case 1 then, and we're gonna do the same for the analogous for the height and width. So we're gonna have height, and instead of 1 it's gonna be 2, and width instead of 2 it's gonna be 3. Great. Like that, we're just implementing the we're just storing our, say, color channels, number of color channels, the height number, and the width number. Okay, so now what else? Well, as we will see when we display the mosaic, it is possible to introduce space in between different cropped images. Okay, so think about this. If we have n rows, say, there's going to be a maximum of n minus 1 space in between these rows. Okay, and we're gonna implement this functionality. Okay, we're going to introduce a variable. There's going to be a spacing that is going to allow us to introduce space in between images. Okay, and to get started, so just as we're starting with this, let's just keep it equal to 0 for simplicity, and later, once we have the say mosaic, we'll introduce some spacing so that we can all see explicitly how it works. Okay, great. But how can we continue now? Well, we're gonna actually define the mosaic. So define the mosaic structure. Okay, and to do so, we are going to just fill it with zeros. Okay, so the plan is the following. The plan is to first construct the mosaic structure, and then what we're going to do is to replace all these zeros by the corresponding numerical representation of the tensor, or the numerical representation of the images, okay, of the cropped images, so that we can end up seeing the cropped images, okay, instead of just 0, so nothing, right, with the 0. Okay, so let's do that. How is going to look? How is this mosaic going to look like? Okay, so let's think about that. Okay, so the mosaic. For now, we're just going to have zeros. Okay, we're just going to have zeros. And okay, so as the first element, we're going to have the color channels. Okay, we're just going to have the color channels, and the good thing about specifically about the color channels is that they are the same for all the images. So we just don't need. It's really simply just having as an input the color channels like that. And now let's think about the following. So in the mosaic, we're going to have it's going to have a certain height, and it's going to have a certain width. Okay, and we got to think about this. We got to think that we're going to have in this mosaic n rows and m columns, right? And essentially, the height of the entire mosaic is going to be dependent on how many rows we have. So what it makes sense is to say, okay, we're going to have h as, because remember, h is the height of one cropped image. Okay, so but here we're looking at the height of the total mosaic. So then what we need to do is, okay, say take the height of one image, of one cropped image, and multiply it by the number of rows, of our mosaic. Okay, so in this case, we define it above. This number of rows is going to be the following. Okay, just like that. But is that enough? The answer is no. The answer is no. Why? Because as we explained, we need to introduce spacing. So spacing in between cropped images. Okay, so to achieve this, we simply need to add. So we need to add this variable, okay, of spacing here. Okay, the spacing variable. So essentially, in that way, we're going to take into account the spacing that can be placed in between rows. But okay, just like that, we're just taking into account the spacing between just say consecutive rows, right? But we want to take into account the spacing in between all rows, all of them. So remember, the maximum possible say number of spacing is going to be equal to the number of total rows minus 1. Okay, so in that case, we just simply need to say, okay, number of rows and this minus 1. Great. In that way, right now, all of this is taking into account the height of the mosaic. Okay, great. So let's continue now, because now we'll need to do the analogous with the actual width of the mosaic. Yeah. So, and it's completely analogous. So what we're going to do now is just to, instead of taking into account the height of one row, or better say the height of a single cropped image, what we're going to do is to take into account the width of a single cropped image, and that needs to be multiplied by the number of, in this case, columns, because in each column we're going to have a cropped image, right? So we need to multiply by that, and then instead of rows now we're going to have columns, of course. So it's completely analogous. Great. In that way, we already gonna have the essentially we're gonna already have the structure of the mosaic completely defined. Yeah. Okay, so what is next? So now what we need to do, what we need to achieve is actually to get so essentially to get a method that is able to place every cropped image in the corresponding position of the mosaic systematically. Okay, and so how can we achieve such a thing? Well, let's think about that. Let's think about it for a while, because it's something that is worth to spend some time on, in order to say deeper the understanding of it. So get a better understanding. Well, so how can we do it? Remember, we said we're gonna work with tensor, a simple tensor with 6 crop images and 3 color channels, 2 as a height, 3 as a width. Yeah. This means we're going to have a distribution of, say, we're going to have 3 columns and we're going to have 2 rows. Yeah, in our distribution here. So we need a method that starts from the 0th position and then scans in the following way. Say, start with the 0 position, then go to the first, go to the second. Okay, so we start from the, say, let's focus on the columns now. So if we focus on the columns, we need a method that starts at the position 0, then goes to 1, which would correspond to the second column, and then to the following, which is the third column. Okay, so 0, 1, and 2. But once it's time to move to the say following image, remember we're going to have a distribution of as we saw before. Let's actually showcase it again for the sake of clarity. Okay, so remember, yeah, we have 3 columns and 2 rows. So we need a method that places our image in the so first column, first row, okay, second column, first row, third column, first row, and then once it's time to move to the second row, we need to restart this process. So we need an operator that has this cyclic property of going, in this case, the specific case is going to do 0, 1, 2, and then start again from 0 and do 0 and 1, okay, in this case, and 2, because there are 6 images, right? So we need that. And what kind of operator is going to allow us to do this? So that is the modulo operator, okay? The modulo operator, remember what it does is to give us the reminder of a division, okay? So what we're going to do is to take, actually what we're going to do is to loop through the number of cropped images. That's the first thing. So let me uncomment this. Okay. So what we're going to do now is to look, we need to look through the number of cropped images. Okay, number of cropped images. And what is T really? T is the actual index, is the index of the corresponding image. Of the corresponding cropped image, okay? So let me go here to illustrate better, like aside, okay? So imagine, remember, we are gonna have 6 images, okay? And we're gonna have 3 columns and 2 rows, yeah? So we're gonna use, so in this case, T, we're gonna have 6 images, yeah? So in this case, then T is going to be essentially the following. It's going to be just the indices corresponding to these number of cropped images. So it's going to be 0, 1, 2, 3, 4, and 5. Yeah. So 0 is going to be the index corresponding to the first cropped image of the first cropped image, and so on. Yeah. That's going to be T. So what we want to do is, remember, to get this cyclic property implemented. Yeah. And remember, because the main goal is to be able to identify in what column is our tile or cropped image, okay? And to do that, we use the modulo operator. That's the main idea. Okay, so what we're going to do is, okay, let's start with the first cropped image that is going to have index corresponding to 0, and what we're going to do, we're going to divide it by the number of columns. We're going to divide it by the number of columns, and you're going to see why in the result, why this makes sense. So we're going to have 3 columns, remember, in this example that we're following. So the modulo is going to give us the reminder of the division between 0 and 3. Yeah, and of course that's going to yield 0. Yeah, and now we just need to keep doing this. We just need to now loop through. So loop through the, say, let's keep moving with the indices and dividing it by the number of columns all the time. Okay, let's see what happens if we do that. So now we move to the next image, index, and so on. Okay, so we keep doing that with all 6 images. Remember, we need to do this with all 6 images so that we can actually see how it works. Okay, so we have first, second, third, fourth, fifth, and sixth. Okay, and let's see what happens. Okay, you see, so this is exactly what we wanted. This is exactly what we wanted, because as you can see, what's happening is the following. This is indicating us, okay, the first image is actually in the column 0. Then the following image is going to be placed in the second column. Then the third in the third column. Then the fourth image, the fourth cropped image, is going to actually be placed again in the first column. Why? Because of course it's going to be placed in the second row. Okay, and so on. So this is exactly what we wanted. So let's actually implement this in our loop. So we're gonna have the following. So the following equation is going to tell us in what column is our tile. Remember, tile, when I say tile, is saying that cropped image. Okay, so in what column tells us in what column is our tile going to be placed in. So tells us in what column. It's a bit tells us in what column. Tells us in what column our cropped image is going to be placed in. Yeah, I mean, cropped image tile, it really doesn't matter. It means the same thing. Okay, so then this U indicates the column index. Okay, U is equal, U means column index, and then we're gonna have the index corresponding to the cropped image and modulo number of columns. Okay, great. That's clear. So now what we need to do is to find an analogous formula that tells us the column where our cropped image is. Sorry, not the column, the row. Okay, we need to find an equation that tells us in what row is our cropped image going to be placed in. So what kind of equation, or what kind of say operation can give us this? Okay, so the operation is essentially the Python division with double slash. Okay, why? Because that is going to essentially tell us where the row where our image is going to be placed in. Okay, so let's see how it works. So we're gonna have again, we're gonna have the index, and we're gonna be dividing by the number of rows. Number of columns. So we just need to do this again for every image. Okay, so every cropped image with its corresponding index. Okay. Great. So indeed, remember, because what this division is doing, remember, is rounding down the answer. Yeah, it's rounding down the answer. So this is why we're getting 0 here. Yeah, but essentially, you see, this is telling us, look, your first cropped image is located in the first row. The second also in the first row. The third is also in the first row, and so on with the following examples. Okay, so the combination of both, both equations tell us exactly the position where our cropped image is going to be placed in. Okay, very interesting. So now we do the same. So we implement the same thing here, but now for the rows. Okay, so it tells us in what row, and our cropped image is going to be placed in. And now the row index actually is going to be v. Yeah. Fantastic. Yeah. Great. So now what can we do? What should be the next step? So the next step is actually to replace the zeros that now, look, are filling our mosaic. Yeah. And replace them by what? By the actual numerical representation of the cropped images. Okay. And how can we do that? Well, we need to slice through the mosaic. We need to slice through this object here. And to understand this, let me show you a diagram. Okay. So this is just the example that we're working with. This is just the very simple example we're working with. We have 2 rows, 3 columns. Okay. And you see I placed here different points, and these indicate essentially the coordinates, we could call it, of the images that are contained in the mosaic. Okay. So essentially, this is what's happening. We start from the 0, 0 position, and the 0, 0 position corresponds to the top left of the mosaic, and we're gonna have that U, remember, U is the column index, and a V is the row index. So in this case, we are in the 0, 0. If we move towards the right, then the row keeps being 0, of course, but now we move to, say, the first column here. And then we move to the next column, hence U is equal to 2, V keeps being 0. If we move then to the, say, second row, okay, we're gonna have yeah, basically b is equal to 1, okay, and u is equal to 0, but so on. You already see how it works. Okay, so what do we need to do here? What do we need to do here? So we need to establish what is the starting point and what is the end point of each image within the mosaic. Okay, and what do I mean by that? Okay, so let's analyze. You see, you already see that by default I framed the top left image here. Okay, so let's focus now. For now, just let's focus on the height. Okay, just focus on the height, which is this these 2 lines. Okay, these 2 lines, let's focus for now on these 2. Okay, so let's do it, and we need to find an equation that defines this line, that represents this line. Okay, so how can we do that? Well, let's think about that. So we're talking about height, remember. So height is related with the rows. Yeah, height is related with the rows. So hence we need to work with the v index. Yeah, we need to work with the v index. So let's do that. So v is going to be scaled with the actual height, and to this height we need to add the spacing. Remember, we can actually place space in between rows, so space here and between columns as well, here and here. But again, stress that for simplicity I set space to be equal to 0, spacing equal to 0. Okay, but yeah, this equation is representing this line. Okay, why? Because, well, in this case v is equal to what? Is equal to 0, because we are in this point. Yeah, so essentially this is going to be equal just to 0. Yeah, directly. Okay, well, all right, that represents this first line that limits our first image, because remember, we are focusing on this image only for now. Yeah. Okay, so we have this equation that represents this line. Now let's find the equation that represents this line that limits our the height of our first image. Yeah. Okay, so let's do that. So let's think about that. So we're gonna have again the same structure. We're gonna have v, we're gonna have h, and we're gonna have again scaled with h plus s, yeah? So the row index scaled by the height and s, yeah? Okay, so in this case, what is happening? Remember, we are in the first row, okay? We are focusing on the first row. The first row, yeah, has an index of v is equal to 0, yeah? So this v is also equal to 0, yeah? So actually, no matter the image that you select, rather, it doesn't matter if it's the first or if it's this one at the top, also at the bottom right? It doesn't matter. The index, the raw index, is not going to change, okay, in that particular image. So what does that imply? Well, this implies that this is also going to yield 0, right? But what is the problem with this? The problem with this is that we get the same result for both starting and ending points. So this means that essentially we would not have image in between these two, say, limits. Yeah. So this means that this last equation needs to be modified. Okay. So let's think about how. Well, look. What is the space in between, say, these two horizontal lines that I just draw? Okay, so it's just the height. You see, this space here is h. Yeah, so then we just need to add h. That's all. Okay, and that's going to be the endpoint. And the good thing about this is that this structure is maintained no matter what image you select, okay? And we'll understand that later, yeah? But now it's clear how we can define the starting point and the ending point for our height. So now let's do the exact same, but for the width, okay? So let's just do that now. Okay, so now let's focus on these two, okay, the limit of the width of our top left image. Yeah, so let's first find the equation that defines this left vertical line. So in this case, we are looking at the columns. So rather than taking the row index, we're going to take the column index. So it's going to be u, okay, u times what? So u is going to be multiplied, yeah, so by essentially the scaling factor that is going to be the width now, plus the spacing. Yeah, and again, the spacing is going to be the same in between columns, just like happened with the spacing in between rows. All right, so this is the starting point, and let's go for the end point of the say first image. Yeah, so we're gonna have again these index, this column index, multiply by width plus s, yeah, and we have the exact same problem. Why? Because u is for both is for both say limitations is going to be 0. Okay, because why? Because we're talking about the first image. The first image has always the column index equal to 0. All right, so this means that this needs to be modified, the last equation. How? Well, by just adding the width, of course, the width, because we have here the width. Yeah, fantastic. Okay, that is actually how we define the starting and the points for both height and width when it comes to slicing through the mosaic. Yeah, but let's actually look a bit on another image, because you might say, okay, I want to see why the same structure works for any image. Yeah, so let's do that. Let's do that now. And instead of taking the first, we're gonna take the actual. We're gonna take the image at the bottom right. Okay, so let's do that. Let's frame it first. So there we go. And now let's do the complete analogous thought process. So now let's focus on the height first. Yeah, let's focus on the height first, and let's focus. It doesn't matter. I wanted to use the fact that I already drawn the vertical lines, but anyways, let's focus on the height. Yeah, so the height. The first equation is going to be the following. So exactly the same, but now remember we're focusing on the height, so we need to focus on the row indices. So V is equal to so V is going to be multiplied by this scaling factor, and the scaling factor is going to be, of course, the height plus S. Okay, and what is happening here? What is happening? In this case, remember, we're analyzing this image, right? So what is the index corresponding to this image? Well, it's going to be V is equal to 1. V is equal to 1 because we are in the bottom right. So V equals to 1. And well, in this case, remember, S is 0 because we simplify this problem to be like that. And then the resulting is going to be just H. What does that mean? Well, that always the height that say we have when we frame our target image, our target cropped image, is going to be the height basically that is above it. Okay, in this case, we just have a factor of H. Yeah. Okay, so great. Fantastic. So now what happens? Well, remember, this is just the equation for the top limitation. Now let's do the bottom limitation, which is going to be exactly the same. Okay, but notice now that V again is going to be the same that the top limit, just as it happened before, right, with the top left image. So in this case, we're just gonna have again H. Okay, we're just gonna have H again, but this cannot be. This cannot be because actually, if we were to just have H, well, this image in between wouldn't exist, right? Because this actual H corresponds to the above height, not the in between height. Yeah. So how do we modify this? So exactly the same way that we did in the previous example. So that is just simply add H, and this H is going to be this height. Okay, so now we're taking into account the height that is in between the limits, the horizontal limits, and the height that is above the top limit. Okay, fantastic. Now it's very clear. Now let's look at the width, which is actually more interesting than this, say, horizontal limitation. So this one is going to be like that. So we're going to have this equation, and this equation we're going to have, remember, now we're looking at columns, so we need to be working with the column index, so U, and we're going to have, okay, we're going to have the width now, so we're going to have width scaling like that. Okay, and now the big question is, what is this width, right? What is this width? So this width is going to be equal to the width that is on the left of the selected, say on the left of the actual first vertical line. Okay, so actually this W is really equal to 2W. Okay, it's just written like that, but we just have written W, but it's really equal to 2 times W. Okay, very interesting. Fine. But this is actually going to be the case for the first limitation. So what about the second vertical line? So in a completely analogous way, we're going to have UW plus S. Okay, what happens if we just leave it like that? Again, we wouldn't have this image, okay? Because remember, this W is the previous, so it's the width that is on the left of the first vertical line. This is actually our W here, okay? So then what? Well, we need to add a width. We need to add a width, and this width is actually going to be the width that is in here, okay? So that we have the scaling. But now you can clearly see that we have the same structure of starting and ending points, no matter the image that we are going through within the mosaic, okay? So now that we perfectly understand, and again, this is my thought process, this is the way I understand how to slice through Mosaic, and I am very open, I'm all ears if you have other methods, okay? That's the beauty of coding, right? That we can all come with different methods. So great. Let's continue coding. So now the goal is to actually code these say understanding that we got, okay? How? Well, let's first say, now here in the loop we're gonna say, look, we're gonna replace, so we're gonna replace zeros by the numerical representations. So let's do that. So mosaic, or I think it's pronounced mosaic, but anyways, mosaic. Well, we have this, and remember, we don't have to really worry about the slicing of the corresponding to the color channels, because it's just the same for every image. So we just place the color channels like that, and now what we need to do is to slice the height, okay, the height. So we do it with the starting point that we found with our explanation, which is VH times spacing, and this is the starting point. Where is the end point? Well, it is V H spacing, and then plus H here, in order to take into account the height in between the horizontal lines. Yeah, great. So now let's do the exact analogous thing for the width. Okay, so now instead of U, we're going to have the column index, which is going to be U, and instead of height, we're going to have width. Fantastic. Well, and of course, this is width. Okay, so now that we have done this, well, this is just essentially taking a piece of the mosaic, yeah? But we need to actually replace that piece, right? By what? By the actual numerical representation. And not only the numerical representation, but the normalized, okay, numerical representation. So how did we say in the last video that we would do this? Well, using the capabilities of IMSC, right? Because remember, this function was able to rescale and normalize basically our tensors, okay? So that's exactly what we're going to do. We're going to say, okay, this IMSC, this is going to be equal to IMSC, okay? And remember, the IMSC took a 3D vector, yeah? Took a 3D vector, and so essentially, yeah, so essentially we need to say, all right, so it needs to take the input, yeah, the input tensor, random tensor, and remember, because we are taking so we're looping through the number of images. So essentially what this is saying is take the say tensor that corresponds to the say cropped image that we are looping through in that moment. Okay, so random tensor t, and we're gonna set the functionality of so we're gonna turn off plotting for IMSC. Yeah. All right, and we also need to select here just the first output, because remember, IMSC returned a tuple, returned the rescaled tensor and also the actual plot, right, with handle. Here we just care about the tensor, so let's just select that first element of the tuple. Okay, so once we have that, we just need to wrap it up. How? Well, we have rescaled the images that conform the mosaic, yeah, but we now want to also make sure that the mosaic as a whole is rescaled too. Okay, so that's why we applied again IMSC. We applied it again, and we apply it now to the mosaic. Yeah, and now of course the quiet mode is going to be set to false, because we actually want to see the plot. Yeah, okay, so this should actually work. This should give us a mosaic structure. Let's see. Oops, what happened here? Type must be tuple of you see, one of the most common errors in machine learning, which is a type error. Yeah. In this case, it's going to tell us, look, I don't like but okay, I don't. So we're working with floats, but it's telling us, look, I need tuple of ints. I need tuple of ints. Okay. Okay. This three is a float, right? And this three corresponded to the number of columns. So it looks like we're getting a float for the number of columns, and probably also for the rows. Yeah, also for the rows. So this means that just showcase also for the row, right? So print. Yeah, you see, we have floats for both. So we need to convert it into the integers. So for that, let's just apply int here. Okay, apply int in here, and int in here. Okay, let's see. Great, now it worked, and you see that now we got instead integers. Yeah, fantastic. Okay, so you see how we have, look, these are our cropped images. Okay, and the mosaic is coded so that we have plenty of space for say more cropped images to be filled in. Yeah, but again, this is just a dummy example so that you see how we work with, remember, a random tensor. Okay, here we're working with a random tensor. So how about now we apply these? So this is not in the form of a function. So what we need to do now is to put this properly into a function and run it with our actual data, with our road sign images. Okay, so for that I have here the exact, so this is the function that we just defined, well, that we just went through, but put officially, or say structured as a proper function. Okay, so you see we have as an input we're gonna have a tensor that's having a 4D dimension of number of cropped images, color, channels, height and width. Yeah, just like we have with the random tensor, remember, 4D, number of images, color, channel, height and width. So by the way, just for curiosity, remember what happens if instead of a 3 I put a 2? What's going to happen here? Oops, you see, it's going to yield an error. Why? Because you see it's saying, look, the target needs to be 3, okay, but you got me a 2. What is happening here? Remember, these ImArraySC function is leveraging ImSC, and ImSC only accepts either 1 or 3 as color channels. If you put something else, not gonna work. So you see, if I put 1, it's gonna work. Yeah, of course, now with a great scale. Yeah, fantastic. But let's continue. You see, as an input we have these tiles, that is the input tensor. Spacing we're gonna have, remember, for now we just placed a 0, that's why there's no spacing in between the cropped images, and the quiet of course false because we want it to be plotted. But as you can see, we have this exactly the same logic that we followed previously. Okay, so essentially store the number of cropped images, define the column and the rows, store the values for the color channels, height and width, define the mosaic, and replace or basically looping through the number of cropped images. So we're looping through the cropped images, and then we essentially found a method to be able to identify where our cropped images were located, exactly in what row and what column, and then we replace the zeros by the actual images, the actual numerical representation of the images, and finally we're going to return the rescaled mosaic. Yeah, fantastic. So with this, we just define this function. Okay, this is the function that we just explained, and now let's put it in practice. Let's just have a bit of fun and see how our data is going to look like. Okay, so for that we are going to first load the data. Remember, in our first videos we defined our function load data, which essentially filter the data. So we're going to do that. We're going to say data is equal to load data, and again we chose to go for mandatory, so mandatory. And now we are going to call our function. So imArrays. C. Yep. Fantastic. And Okay, so what are we going to have as an input for our im arrays? Remember, im arrays are the cropped images. We want the cropped images. So remember, in our data set, we had, so first of all, we were using dictionaries. So the data set was stored using the data structure dictionary. Okay, so in this dictionary we had two main keys, so two top level keys, which were train and val, and then within each top tier key we had sub keys. Okay, we had actually 5 different types of sub keys, and remember that the sub key that contained the cropped images were the box patches. Okay, were the box patches. So just let's just print out the trained mandatory cropped images. Okay, so to do that, we just gonna say, okay, data main or top level key in our dictionary, which is train, and the sub key, which is going to be box patches. Fantastic. And the space, we're going to set it to equal to 0. Yeah, equal to 0 just for now. Let's see what happens. Oh, what happened in here? Oh, this is unexpected. This is unexpected because we should only get the mandatory signs. So let's think about this. What happened? Ooh, let's see. We need to have a look at the. Let's just run. Sometimes you just need to run the whole thing above. You see, okay, for some reason we were just getting all different kinds of road signs. But now, yes, now is expected. It's as expected. We get mandatory signs only, and as you can see, we get yes, you see this tensor. These are the tensors that represent the cropped images. Okay, and of course you see how they are rescaled as expected. Brilliant. So again, let's play a bit about with this spacing. Yeah, because you see, I set it to be equal to 0. But what happens if I set it equal to 10? So of course we are gonna have. Probably what's happening is that these load data is defined not in the right way. Okay, load data. Oh, you see here, this should be IMSC. Okay, this is not data, this is IMSC. So I am DB. Okay, you see, because we're within the definition of the function. So I think that was a problem. But anyways, let's run it again. Great. Yeah, that was the problem, definitely. So you see, now we get the mandatory signs. We are getting the mandatory signs, and also what was happening, because before you just saw that we got the mandatory signs, but we got much less, also many less images. Okay, and so that was a problem because we were stating, look, we want all the mandatory signs in the training set. Okay, we want them all, and we were not getting all. Okay, and that was related to the fact that in the load function we were actually indicating this data, which probably was defined above as just having a small number of mandatory signs. But anyways, the point of this is that you see now we have a spacing of a 10. But what if I just now said spacing of 100? Okay, you see how we have all the images are going to be much spread out because of course, having much bigger spacing in between them. And just to play a bit more, yeah, of course, we just see how can we adjust the spacing in between them. Okay, but yeah, that was all I wanted to explain for this video, the entire explanation of how the IAmArrayC function is constructed and what is the functionality. But next, in the following video, what we'll do is to go and explain the actual, what's known as the histogram. So we're going to see a histogram. Histograms and what is the functionality of them. Okay, well, that's all for today. That's all for this video, and I am willing to see you very soon.